Welcome to the Deep Dive. Today we're getting into something really core to programming.
Yeah,
What makes code good?
right. Not just code that, runs without errors.
Exactly. But code that's actually clear, easy to read, and importantly, easy to maintain later on.
And we've been looking at the Foundations of Good Coding section from Youth Code Lab's Code Smart series. It's all about weekly tips.
Hmm.
And we're trying to pull out the real nuggets of wisdom there.
Yeah, the essentials. And the great thing is, this isn't just for like senior developers.
No, not at all.
Whether you're literally just starting out, writing your first few lines, or you've got some projects under your belt.
These ideas apply. They're foundational for a reason.
So, our mission today, let's break down these core ideas from this series. The goal is to give you stuff you can use, well, basically straight away to improve your own code.
Sounds good. Let's do it.
Okay, so first things first. When we talk about good code, what are we really saying? Beyond just, it works.
Well, the Code Smart series points this out really clearly. There's a big difference between code that just spits out the right answer
Right.
and code that's genuinely clean, readable, and maintainable. You can definitely hack something together that functions.
We've all done it.
Oh, yeah. But if it's a tangled mess, coming back to it later is just painful.
Yeah, a real headache, even for yourself, right? Let alone if someone else has to look at it.
Exactly. That's a crucial point. Even for your personal projects, think of future you as another developer.
Good way to put it.
Seriously. When you revisit that code weeks or months later, if it's clean and well-structured, you can pick it right back up.
Understand what you were thinking.
Precisely. Fix bugs, add features, whatever. But if it's messy, well, good luck.
And in a team environment, it's even more critical, obviously. Readability becomes non-negotiable almost.
Absolutely essential for communication, for collaboration, everything.
Okay, that makes total sense. Now, the series mentions something that maybe doesn't scream essential skill at first glance. Naming things.
Yes. Naming.
Variables, functions, files. It says it's a skill, an art form almost.
It really, really is. It's more fundamental than people might think. I mean, imagine you come across a variable just called data. Data for what?
Or temp, temporary value,
Yeah.
temperature, who knows?
Right. Ambiguous.
But what if you see customer address list or max login attempts?
Instantly clear. You know exactly what it's holding, what it's for.
That's the power of good naming. The source doesn't give a specific, like, side-by-side bad versus good, but the principle is clear.
Yeah, you can easily imagine examples.
Aim for names that tell you the what, and maybe even hint at the why or how. Bad names obscure meaning. Good names illuminate it.
So it links back to this other core idea from the foundations. We're writing code for humans, first and foremost, not just a computer.
Spot on. That's a really key insight. Prioritizing clarity for the human reader. Often more important than being super concise or overly clever.
Right, sometimes clever code is just hard to read. Exactly. You might save a few keystrokes, maybe feel smart for a second, but if no one can understand it easily,
Including yourself. 6 months later.
including yourself, the computer doesn't care if your variable name is X or number of active users, it just processes it.
But the next person reading it definitely cares.
They sure do. It's all about reducing that cognitive load, making it easier for a human brain to follow the logic.
Like writing clear instructions. Fewer words isn't always better if the instructions are confusing. So understandability is key. Okay, what about comments?
Comments. Yeah.
We're always told, comment your code. But the series talks about this interesting balance, right?
Yeah.
Comments versus self-documenting code.
Yes, that's a really nuanced point they make. The ideal isn't necessarily just plastering comments everywhere.
Okay.
The goal should be to write self-documenting code as much as possible.
Meaning the code itself is clear.
Exactly. Through like really clear naming, good structure, logical flow, small functions maybe. The code should largely explain what it's doing on its own. Comments then become more strategic. You use them to explain the why.
The why, not just the what.
Precisely. Why did you choose this approach? Or maybe explain a particularly complex piece of logic that isn't immediately obvious. Or provide like a high-level overview of a big section.
So the code tells the story. Comments add the director's commentary for tricky scenes.
That's a great analogy. Yeah. Don't just comment increment count. If your variable is user login count plus, that's probably clear enough.
Makes sense. Let the code speak for itself where possible.
Okay, one more core thing from the foundation section. Consistent code style.
Yes. Indentation.
Using formatters, linters.
Mhm.
This seems almost, I don't know, cosmetic. But the series says it's important. Why?
Well, it ties right back into readability and reducing cognitive load again.
How so?
Imagine reading a book where every paragraph had a different font size and random spacing.
It'd be awful, really jarring.
Right. Consistent style and code indentation, spacing, how you structure blocks it, creates a visual rhythm.
Ah, okay. Like visual cues. Exactly. It helps your eyes and brain quickly parse the structure, see where blocks of code begin and end, follow the flow of control.
And tools like formatters help enforce that automatically.
Yep. They take the guesswork and inconsistency out. Linters go a step further and can flag potential issues or style violations.
So it makes individual code easier to read and probably helps when different people are working on the same code base too.
Hugely. Everyone's code looks and feels similar. Makes code reviews easier, makes collaboration smoother. It just removes unnecessary friction.
Okay, I see how that fits in. It's all part of making the code easier for humans to work with.
Pretty much, yeah.
So let's recap the big takeaways from these foundations of good coding. Number one, prioritize clarity and maintainability right from the start. It's not just about making it work now.
Correct. Think long term. Think future you. Think collaborators.
Number two, naming is a crucial skill. Be descriptive. Be clear.
Make your names meaningful.
3. Remember you're writing for humans, not just the machine. Readability often beats excessive cleverness or conciseness.
Absolutely. Optimize for understanding.
4. Strive for self-documenting code first. Use comments strategically, mainly for the why or for complex parts.
Let the code do the talking when it can.
And finally, number 5, embrace a consistent code style. Use the tools available. It really helps with the readability and reduces mental friction.
Spot on. Those are the core pillars they lay out.
And these might seem like small things individually, maybe.
Maybe. But the Code Smart series intro really hits this home. Mastering these basics is what builds your confidence and your competence as a programmer.
It's about building good habits.
Exactly. Habits that pay off massively down the road. You end up with code that not only works, but is actually, pleasant to work with.
That's the goal, right? Pleasant code. This has been super insightful, really drilling into what makes code good at its foundation.
Glad we could dig into it.
Okay, so for you listening, here's a little something to think about. Consider a piece of code you wrote recently. Doesn't have to be complex. How could you apply just one of these ideas we talked about today to make it just a little bit better?
Yeah, just one thing.
Maybe look at the variable names again. Is the indentation perfect? Could a quick comment explain the why behind one tricky line?
Give it a try next time you're coding.
Yeah, explore that. You might be surprised how even a small tweak based on these principles changes how you feel about your own code.